Leetcode question 25. Reverse nodes in K group. Given the head of a linked list, reverse the nodes of the list K at a time, and return the modified list. K is a positive integer and is less than or equal to the length of the linked list. If the number of nodes is not a multiple of K, then left out nodes, in the end, should remain as it is. You may not alter the values in the list node. Only nodes themselves may be changed. So in this example, example 1, given the linked list, K is 2. So basically, the groups are divided in terms of in elements of 2. So in that case, so for the first 2 elements, we swap them, we reverse this linked list. And then for the next 2 elements, we also reverse. And then we have one remaining element in the end, just one. So the left out nodes is not a multiple of K. So in that case, we just let this file remain as it is. In the second example, K equals 3. So in that case, we reverse in the group of 3 nodes. So we find the first 3 nodes and then we reverse them, and then we have 2 nodes left. So those 2 remaining nodes, because it's not a multiple of 3, so in that case we just keep them as it is. So the idea to solve that is within each group, we're just trying to reverse the linked list. So if we just look at each group, that is equivalent to the Leetcode question of reverse linked list. And then now we need to actually reverse the linked list within this group. So what we need to know? We need to know the node before the current group. We call it group previous node. And we also need to know the first node in the current group. And then we can actually deduce or infer that from group previous. So that's just the next node. And then we also need to know the end node in the current group. That is the case node in the current group. So it's the case node after this group previous. We call it case node. We also need to know the node after current group. So that's the next node of this case node. So the step for step 1, we figure out we only need to track the group previous variable. And then we can deduce the following. Basically, group previous.next, that's the first node in the current group that we are going to reverse. And then case node is the case node after group previous node. So that's the end node in the current group. For this one, we probably need a function called getCaseNode in order to get this node. And then we also need to know the end node after the current group, the node after the current group, that is caseNode.next. So in this case, we already figure out, okay, we need to implement a function, a helper function to get case node. And we also need to track the group previous node. And then for the second step, after having those information, we just reverse the K nodes in the current group. So before, the same logic as what we did in reversing the node. So before reverse, previous.next, just current. After reverse, current.next is previous. So basically, if you look at this diagram, we just switch the directions of these arrows. So it's now point from left to right. When we reverse, we just point from right to left. That's kind of how we reverse it. So in this case, similar as before, we need a previous pointer and then a current pointer. For the initialization, the previous pointer is a node after the current group. And then the current pointer is the first node in the current group. So similar as before, current node is always the nodes in the current group. And then for this previous one, because after reverse it, the first node in the current group will be the end node in the reversed group. So in that case, this end node this end node's next node should just be the node after the current group. So basically how we figure out the initial value. So for step 2, so basically we are just trying to reverse the k nodes in the current group. And then how we are reversing it, basically we are reverse the direction of those arrows. So basically previous node dot next is current node, and after reverse, we are reversing it by set current node dot next is previous node. So that's kind of how we reverse the direction. So in that case, for current node, it should initialize to be the first node in the current group. So basically as we are moving the current node and reverse it one by one, it should always be the node in the current group. And then initially it's just the first node in the current group. And then what is the initial value for this previous node? It can be a little bit tricky, but let's think of it this way. So basically after reverse, the first node in the current group becomes the end node in the reverse group. And then for this end node, the next node should be the node after the current group. So in that case, we can set current.next is previous. So in that case, after this reverse, this current node's next should be the node after the current group. So in that case, we know, okay, for initially, we should initialize this one to this value. So for step 3, after reversing the k nodes in current group, we need to connect them with the adjacent nodes of the group. So basically, before reversing, the first node of the group is just group previous.next, and then the last node is just kth node. And then after reversing it, so this kth node becomes the first node. So in that case, we should connect this node, the new first and the last node, with its adjacent node. That's what this step does. So in that case, last node.next is just the node after the current group, because we only reverse the nodes within the current group. So their neighboring nodes remains the same. So in that case, we just need to connect the updated first and last node with the adjacent nodes. And then for the node before the current group, the next node should be the updated first node. So in that case, we can combine these two. That is just group previous.next is just kth node. For the step 4, we need to prepare for the next group. That is, we need to update this group previous to be the last node of this reversed group, so that it will be the previous node before the next group start. So in that case, group previous is just updated. Group previous is just updated to its next node. However, so in step 3, we already noticed, okay, this one is updated. The next node of this group's previous node already updated and overridden. However, for this step 4, we still want to use its original value. So in that case, the trick we can use is to use a temporary variable to store the value. So that's kind of the step for solving this problem. Let's start coding. Okay, so what we need to have right now, so we need to have a helper function. So we figure out from this step, we need to have a helper function. So let's copy paste this helper function. Basically, let's just define this helper function. And then just let this to be the current. So basically get kth node after the current node. And then we also need to track this group previous. And then initially, it should be the dummy node. So let's use the dummy node. So dummy So that dummy node is the node before the head of this linked list. Initially, dummy is just group, previous is just dummy. And then we need to call this case node for each group. So to get the case, we need to get the case node for each group. And then in order to do that, after we get the case node, if we can return a value from the case node, which means, okay, the current group, the remaining elements has more than k nodes. So in that case, we can just reverse the nodes in the current group. However, if this function returns null, which means we do not have sufficient elements or nodes remaining. So in that case, we do not need to do the reverse. We just remain the nodes as it is. So whether or not we are actually reverse the remaining elements depends on if the number of remaining elements left is greater than or equal to k. So in that case, we should wrap this one within a loop. And then we can wrap it with while true. So it will always be true. But if this case node if the return value is none, so in that case we just break because we do not need to do any reverse operation. And then let's suppose we get a case node. So after that, we need to do reverse. Reverse the k nodes in the current group. So in that case, we need to have previous and then the current. And then initially, the initial value should be case node.next. And then also the first node in the current group, that is group previous.next. And then let's have a count. Count variable is just 0. We just need to reverse k nodes. So in that case, we'll count less than k. We just do the reverse. So reverse current.next is just the previous. And then we also need to update the previous and the current. So this should be current and then current.next. Basically, we are shifting towards the right by one node. However, since this current.next was already updated in the previous step, in the previous line, so in that case, we need a temporary variable. To store the original node for the current.next. And then we also need to update the count by 1, by increasing 1. So that's kind of the second step, reverse the k nodes in the current group. After that, we need to connect with the group adjacent nodes. And then also prepare for the next group. Here, since this one is already updated in previous line, in line 58, So in that case, we also need a temporary variable to store this. And then in the end, we just return the head, return dummy.next. So right now we still have this get case node remains. Let's implement this one. So basically for this one is while current, and also this k is greater than 0. In this case, we just shift to the right. And then we just return the current. So let's run this solution. Okay, it's not reversed. Let's try to debug this one. So we get the case node. So we have a dummy, and then we have the group previous. It's initialized to dummy. And then we're trying to get the case node. If not case node, we just break. Otherwise, we're just trying to reverse the case node in the current group. So this previous should be the case node.next. And then this one should be the current should initialize to group previous.next. And then this count, well, this count is less than k. So we just current.next is previous. And then after that, we update previous and current. And then also increase count. And then after finish switching, we need to connect with the group adjacent nodes. So in that case, this is the original first node of the group, but now it's the last node. Okay, so for this one, okay. Okay, that's the combined line. Group.next is just the case node. Group previous.next is just case node. And then this group previous is updated to group previous.next. And then let's check get case node. So that is, well, this current node is not null. And then this k, okay, we forgot to update this k value. This k should -1 in each iteration. And then let's run this updated solution. This solution is accepted. So basically for this one, the idea is to track all the relevant nodes that is defined in this step 1. And then in the step 2, we just reverse the k nodes in the current group. And then after reversing, we need to actually connect the first node and the last node in this reverse group with the adjacent nodes outside of this group. And then after that, we need to prepare for the next group by update this group previous.